A solenoid 50 cm long has 4 layers of windings of 350 turns each. The radius of lower layer is 1.4 cm. If the current carried is 6 ampere, estimate the magnitude of magnetic flux density 1. Near the center of the solenoid on its axis, 2. Near the end of the solenoid, 3. Outside the solenoid near its center. The formula we are going to use are field well inside the solenoid is B is equal to mu 0 Ni, where small n is the number of turns per unit length and I is the current through the solenoid. The second equation is magnetic flux at one end of the solenoid. It is B is equal to mu 0 Ni by 2. And magnetic field at a point outside the solenoid near its center is 0. So these are the equation we are going to use. So let us collect data from the problem. Here the solenoid is 50 centimeter long. So length of the solenoid L is equal to 50 centimeter or 0.5 meter. Number of turns capital N is equal to 4 into 350. Here we have 4 layers of winding, each of 350 turns. So 4 into 350 gives the total number of turns. Number of turns per unit length, small n is equal to capital N by length, that's N by L, 4 into 350 by length 0.5, that is 2800 turns. Current inside the solenoid is 6 ampere. Now we can first find the magnetic field well inside the solenoid using the equation B is equal to mu 0 Ni. Mu 0 is 4 pi into 10 raised to minus 7. N is 2800 and current I is 6 ampere. So the answer is 2.11 into 10 raised to minus 2 Tesla. Next we have to find the magnetic field near the end of the solenoid. We have the equation for magnetic field at one end of the solenoid as B is equal to mu 0 Ni by 2. That is 2.11 into 10 raised to minus 2 by 2. That is 1.05 into 10 raised to minus 2 Tesla. And third question is, we have to find magnetic field outside the solenoid near its center. Outside the solenoid, magnetic field is negligibly small or almost equal to 0.